Okay, this is a quick look at the beginning of Unit 3 in specific lesson 3.1. So 3.1, if I look at the opening lesson narrative, I will see that lesson is first of 4 lessons where students will work with proportional relationships from a grade 8 perspective. And also embedded alongside that, proportional relationships, students will learn about graphing from a blank set of axes. And things like attending precision and how they label and choosing scale and drawing lines are all skills that students are going to work on in this lesson, and really for the first 4 lessons especially. So the purpose is to get students thinking about what makes a good graph. We're also going to be bringing up their previous knowledge about proportional relationships. When we meet, we'll be looking at activity 3. So here's activity 2. And here's activity 3, moving twice as fast. And in activity 3, it points out that an important aspect of this activity is students making connections between the different representations. So to get us ready for our work together with activity 3, I wanted to look at the first few activities, starting with what we're trying to accomplish. So one of the things we're trying to accomplish is having students know how to graph from a blank axis. That includes putting labels on their graph, deciding the scale, which might even mean looking at the numbers in the problem to see how they need to go, and what they're going to count by, ones, twos. What units they're going to use should be shown on the graph, and also some precision. This type of labeling is going to make things uneven and not look linear, so we want them to be precise as they count out their graph if they draw one themselves, and maybe use a ruler to be able to get those lines great. In addition to their blank axes work, which is a big part of the first 4 things, we're also going to be looking at proportional relationships review, trying to bring all of those things up from 5th grade. And we're going to try really hard to be connecting situations to a graph, which is what's going to happen in this lesson. Also, presenting that situation in a table and in an equation. So throughout this whole unit, this graphic is something you can bring back and say, what did we do today? Oh, we took an equation and we figured out the graph. We took a situation and we made a graph or a table. So that will be a nice reference point. Okay. In the proportional relationship review, just to remind you, because you've been in Unit 2, from a table in 7th grade, students learned that all proportional relationships began at the point, or at least included the point 0, 0. And when they had a set of points from data, they noticed that each point would have the same multiplier, and that multiplier was called the constant of proportionality. Also, they learned that if they would work backwards, like maybe by dividing this 2 in half, this would have been a 1 and this would have been a 3. Like if 2 cups of rice served 6 people, then 1 cup of rice would serve 3 people. They learned that when they got to this place where 1 was the x value, this y value was called the unit rate. 1 cup of rice for every 3 people. Okay. So notice that this unit rate is the exact same as their multiplier or their constant of proportionality. So if you think that 7th grade learning is something you're going to have a hard time remembering all of that, if you want to pause this video and write notes to yourself, I put that all down, everything I just said down on there. So that's what we want them to remember about a table and proportional relationships. From a graph, they learned that the graph was going to go through 0, 0, through the origin. And that if they went to the point 1k, they would see the unit rate there. When x was 1, they would be able to find the unit rate or that multiplier, that constant of proportionality. To our 8th graders, I think that will feel a lot like a scale factor, what they're scaling from x to get to y from the last chapter. And then As an equation in 7th grade, they learned that y equals kx was a way they could represent any proportional relationship, where that multiplier, that unit rate, or constant proportionality was multiplied by x. So if the unit rate was 1 pound of oranges cost $4, then you could put y equals kx, where y equals 4x, where the number of pounds you bought produced the total cost of those. So that's just a review. That's the things we want to bring up. Now we're going to go ahead and look at how they do that in the lesson. So I'm going to give you this when we meet, and we'll be able to take those notes down here. But if you wanted to take them more leisurely, you have this video to do that. And now I want to look at this warm-up that the lesson starts with. And it's a notice and wonder about 2 graphs. Remember, we're trying to bring up what makes a good graph. And so you ask the students, I want you to write down at least one thing you notice about the graphs and one thing you wonder about the graphs. And I think they will probably notice that this graph, they can tell more what it's about because it has labels on it, including the units. Someone might notice. This one has 2 lines where this one only has 1. They might not know what this one's about. They might assume it's about the same thing, but they might not know what this one is about because it doesn't have any labels. They could notice that the x-axis is counting by 2s while the y-axis counts by 1. That's something we want them to have to decide when they make a graph. What are we going to count by? But you don't count by 2s for a while and then count by 1s. You have a consistent scale. And they might wonder, what are these dots here for? And since we know from the review that when x equals 1, the y value shows us the unit rate or constant proportionality, that's what those are leading toward. But right now we just want to bring those things up because the very next problem they do has a graph, and it has a lot but not all of the things that they liked in the first half. So if I was starting this one, I might have them first look at the graph. Does it have all of those things that we found in the graph that we liked and could understand? Yes, it definitely has the labels, and I can see the name on the 2 different lines, U and V. I don't really know what U and V stand for, but it doesn't have any of the numbers, so I can't tell what they're counting by. So this graph is good but not perfect. Like, I wish they would have put those numbers. I also kind of wish I knew what U and V were. But that's the thing that we're going to decide by looking at this situation. You might remember this situation from last year because I know we had a little bit of difficulty thinking about a graph where we put distance across the x and time across y. As I've thought more about it and actually noticed the apps I have on my phone, I noticed my walk app tells me that if I walk at a 10-minute mile, 10 minutes per 1 mile, right? Then I burn so many calories, but if I walk at a 15-minute mile or a 20-minute mile, then I burn different amounts of calories. And as I walk, my app will tell me, currently you're doing a 17-minute mile. Oh, now you're doing a 21-minute mile. And I'll hurry up. And so that minutes per mile that my app gives me, which cross-country runners maybe take as their splits, right? They, that is consistent. So if you think about these bugs racing, and this shows their splits, how many seconds per centimeter they're traveling, that's what this graph is about. So you're going to want the kids to approach this, and I tell you that if you look to the homework, you're going to want them to be able to use a table. So if a table isn't their natural way of approaching it when you give them time to start, or if a lot of kids are stuck, suggesting a table to organize the information that's up here and help it make sense down here is a good way to go. I'd love to see how they approached it first, but if you get a lot of blank stares, a table is a good suggestion because that feeds into the homework that they'll have to do by themselves later. So this says a ladybug and an ant move at constant speeds. The diagram with tick marks show their position at different times. Each tick mark represents 1 centimeter. one thing that you'll need to decide is how they're going to count where the bugs are. What shall we call the start? And most of the kids agree that we call the start 0. So 0 is a good thing to call that. And then if we're trying to measure where this bug is now, what we have to notice is that when they were measuring the bug at 0, his head was where they were measuring from. So this is where that bug's going to be now. So if this is the start, 1, 2, 3, 4. Now the ladybug is at 4. So I would not let your kids go too far before agreeing how we're going to measure that. And just to speed you along and get you ready for our conversation, if you explore with it, we would need to decide what we want to be our x value and what we want to be our y value. If you'd like, you could label those with different letters, but for now I just put x and y. So looking at the x-axis, I see distance traveled. So this is going to be distance in centimeters. And on the y, I see elapsed time. You ask the kids, what does it look like the x is in the graph? What does it look like the y is? And the elapsed time is in seconds. Okay. And so we have 2 different bugs to chart. We'll probably need a second graph for the second bug, right? And just to get started, it should have the same x and y because it's on the same graph. And so just to get them started, if they're still staring, you might be asking, how will we know the distance by looking at this situation? And hopefully they can know the distance by counting. Okay. So at this spot, he was at 0. At the next one down, the ladybug was at 4. I'm going to write down that this is the ladybug so I can remember. Okay. And then ask them, how will we know the time? We can't count that. Oh, over here it happens to tell us. So in the first measure, they were at 0. At the second snapshot of Fabulous Race, they were at 2 seconds. It had taken 2 seconds. And so they will count to fill out the first column. That's the distances. And they will read over here to see what time this snapshot of the race happened to fill out the second column. If you have them do that, that should orient them. Then you're going to talk about which one should be which is the ladybug and which is the ant. They're going to practice reading points off their graph. How long did it take the ladybug to travel? 12. And then scale the vertical and horizontal axes. This piece, there's more than one right way to do. And that gives you a really nice chance to talk about the scale decisions that they will make. So they could count by 1s, and it will match the graph. Or they could count by 2s. So long as they counted both of them the same, both by 1s or both by 2s, it will work. If they decided to count both by 5s, it would work. So long as they're counted by the same thing, it will match these graphs. So as you're walking around, you might look for one person that's scaled by 1s, one person that's scaled by 2s. And a place, it says in the teacher's edition, but a thing to bring up is eventually they're going to ask us the time after 1 centimeter. And it would probably be handy if you were counting by 1s, because if this is like a 2 or a 5, then trying to guess where that 1 is pretty challenging. And so that would be an issue. Okay. So this is where we're at so far. When we meet together during your PLC, we'll begin at problem 3. So if you need a little time to think and process about this problem, I want to encourage you to go ahead and work this problem and make those charts for yourself to think about it. If you can think another way that a student might approach this besides starting with tables, I'd love to have you bring that idea, because we're going to be thinking about what different ways students might approach these problems. So thank you. I hope that helps speed our discussion when we're working on the 5 practice work for activity 3 in this lesson. See you soon.